talk to you about Geotech Australia, which is the company that we created to make rain. We have two main purposes. The first one is to create rain to reflect UV light back into space. And the second reason is to make clouds for rain to fix a failed monsoon. We have a basic team structure with one project manager and 4 team leaders. The 4 different teams are launch and landing, trajectories, payload control, and rainmaking team. I'm now going to pass you on to James.
So like most large weather balloon type projects, the design mainly revolves around the payload. Payload is used to deliver the rain-making chemicals and disperse them into the clouds. To do this, it needs to be at a certain altitude and position above the Earth. That's where trajectories come in, and they can ensure that the balloon can lift the payload and keep it at that position. The launch and landing team are in charge of ensuring that the rain-making chemicals, the payload, and the balloon material are transported safely to the launch site and efficiently launched and landed. Sean will now tell you more about the launch and landing team.
Hello everyone, my name is Sean, and I'm the MAC team leader. Our team is taking care of the launch, landing, and transport. Our team goals is to acquire sufficient working space for our design and to also gain the protection ability, movability, and also we want our design to be very easy to maintain after the launch and the landing. Well, in pursuing our goals, actually we're keeping the word survive in our mind. So we want our design to survive in any weather condition, and we want our payload to survive during the landing, and we want the equipment to survive during the transport, especially those chemicals. We don't want to cause any explosion during the transport. So this is our basic design. It is called a moving castle, which is used to, which is modified from a freight container, so it's very easy to build and maintain. Well, there are some vital connections between our subteam and other subteams. For launching, we have connections with guided trajectory because we want to launch the balloon to a certain altitude. And for the landing, there's connections with autonomous payload subteam and the guided trajectory subteam. And for the transport, as I mentioned before, it is vitally connected to the rainmaking because we don't want any chemical to explode. Also, I'd like to introduce a fail-safe system, which is designed to sit between the string and the parachute. So basically, the fail-safe system is combined with 2 parachutes. So if anything goes wrong in the sky, we don't want to destroy the payload. So the first lid will open and the parachute will come up. And if it didn't open, we also prepared for the second parachute. So in case to save the payload. Now I'll pass it to the rainmaking team.
I'm Henry. I'll take care of the rainmaking team. Our main goals are to develop feasible ways of cloud seeding, creating artificial rain, and increasing the reflection of the sunlight. The chosen method for the rainmaking and cloud seeding is an adaptation from what currently is used in airplanes, which is a solution with that flare silver iodide and sodium acetone. Other possible ways that we could adapt was use dry ice. That was our second option, but we found more articles saying about the silver iodide, so we chose the silver iodide. We could use silver iodide in rockets. It's a ground method currently, but we might get some destabilization from the balloon. In the laser seeding and hydroscope seeding are 2 possible ways that is currently under research, but still need more research before a commercial application. And the drop zones with silver iodide that was a solution that we currently developed, so was never tested, and would solve the problem that from a balloon that's in a higher altitude for reaching targets that it's a lower altitude would release small balloons. The increasing reflection problem, it's based on the surface temperature is proportional to the incoming radiation from the sun, minus the outgoing radiation from Earth. Increasing the reflection of the sunlight would decrease the incoming radiation as we wouldn't reach the Earth. The method that we couldn't choose for increasing reflection was spraying aerosols in the stratosphere that would manage to give back 0.5 watts per meter square back to space. But we've seen with these amounts that we got that it's currently unfeasible to do it with one balloon and one flight only. I'll now pass to Brian of the trajectory scene.
I'm Brian. I'm basically going to explain on the trajectory side. The main goals of the trajectories is to guide the balloon. So we extend the sub-goals is to actually focus on the balloon, the radar, reflection, and the tether. So initially the client wants us to guide the balloon trajectories, and rainmaking team has proposed that we come up with an S-shaped path from location A to location B and a fixed point. So these three paths are basically proposed by rainmaking. However, we actually have seek an advice from NASA, and it's actually not feasible for this approach. So the NASA team has actually advised us to actually look into the climatology, to look into wind directions. So we got to predict the balloon trajectories. As mentioned by Hendrik on the rainmaking side, apparently aerosol dispersion may not be feasible. So at the point of time, our team has agreed to guide the trajectories via the theater. So this to give you an idea of the balloon, we'll be using the helium gas, and the overall extended equation, the general equation will be this. And we've calculated that assuming that it's 240 kilogram of mass payload, and the calculated diameter will be at least a minimum of 8 meters, and the volume of the balloon will be 236 cubic meters. So we'll be using a GPS to trace the balloon, and the material of the balloon varies, so it has a trade-off within that. So it can be latex, chloroprene, or mylar. At the meantime, we are looking to latex for because of the biodegradable properties. It's 100% biodegradable. If it fails, we might also look into chloroprene because it's an improved version of latex. And mylar is the best, but however, it's non-biodegradable. So these are the trade-offs that we might look into it. And when we purchase the balloon off the shelf, these are the information that we can obtain from the diameter, the shape, the volume, the rate of ascent, and the burst altitude. Just to give you an idea, as we go up the altitude, the temperature will reduce and the atmospheric pressure will also reduce. So if we go up to the tropopause, which is a point that we're going to, from around here that we're going to do the rainmaking. So when the temperature reduces, it's cold up here, it's about minus 55 degrees. So it causes the material of the balloon to freeze. So when the material of the balloon freezes, when the pressure reduces, it causes the volume of the balloon to increase at the same time. So it undergoes a brittle fracturing, at the same time it bursts at around this point. So depending on the material, it varies, so the burst altitude will also vary. And we know that commercial aircraft flies around 9 to 12 kilometers. So radar is actually to design so that we are reflecting the microwave radio waves so that the aircraft were able to detect our payload and as well as our balloon. So it is made by aluminium sheet, a diamond shape, a radar diamond shape, which is about this shape. And it's at least 1.5 meters above the payload. So looking at the tether, we will be actually forming an area of eye bolts to use to secure this tether to the payload. And we will be hiring the winch from Winch Hire Australia to secure this at the moving castle. So it's going to be made of nylon. It's about 10 millimeters in diameter. So to give an idea of these are the main information that other teams required. So the size of the balloon, the volume, the gas, and the length of the tether is what the other teams required for their further calculations. So I'll pass this time to the payload system.
Hello everyone, my name is Chuck, and my team is in charge of to design a payload control system that it automatically attached to the payload. So we have seen some of the team leaders presented the idea, how do we carry the whole system to a launching site? How do we actually launch it? And then where do we want to position the balloon? And after all, it all comes down to the payload control system to actually release the chemical when we get the signal that we want to release the chemical now. So, so the flow is that we will have some information get it from the other team, the rainmaking team, about the environment. So about the wind direction, the wind speed, and the moisture of the environment. And this information will pass down from the payload to the ground control and be analysis. And this analysis will be sent back to the balloon again and to the automated control system. And here's where my team will be in charge of releasing the chemical. Yep. So there's basically one vital connection between, two vital connection between me and another team. It's a rainmaking team. So as I said, my team need to gather data from about the environment and to analyze it. And at the last, we have to know what sort of chemical we are releasing and what sort of releasing mechanism we want to use in this specific environment. So we did some research, and this is a external company that proposed. It's called ejectable material rack. So basically, this thing will be attached under the payload, and then when we get to a specific location, it will release the whole bottom bit, the rack, to the cloud, and then when it's actually go to the cloud city part, it will release the chemical. Yep, and that's it from the team.
So now I'm going to bring you all of the stuff together, so how it works together. So the balloon, the trajectories team will get a balloon design from a company. Then it will be attached by a tether to the radar so that it will be able to be picked up by aircraft. The fail-safe system and the parachute system will be below that. And then there'll be a bearing so that the core doesn't wrap up when in flight. Then there'll be another radar system so that when the balloon and the payload separate, they'll still be able to be picked up by aircraft. There'll also be a GPS in the payload and the balloon so we can keep track of where they are at all times. Then there'll be the second tether between the payload and the winch / moving castle, and there'll be a bearing in that as well to make sure that it doesn't twist. I hope you've enjoyed our presentation. Are there any questions?
I found it difficult to understand why you made some of the design choices you appeared to have made. It wasn't clear to me what your key criteria were. Can you explain to me what your key criteria that have led to a lot of the design choices that you've made are?
So in terms of the...
Why did you choose, for instance, the balloon structure you've got and so forth?
Okay, so we chose this balloon because it was directly related to the payload size. So firstly, we got from the client that we needed to have aerosols to spread into the atmosphere to reflect back UV, as well as do cloud seeding. So we get the two different chemicals, which are the silver iodide and the aerosols, and then the payload was decided by that. Like the size of the chemicals was dependent, and it caused the payload size. And then we decided not to use the aerosols anymore because it's not viable with the amount that we needed. And then because of the payload size, we then chose the size of the balloon from that. And the three different types available for the size we needed are the three different materials that were provided. And so these three different materials, we haven't decided which one will be the best yet because we haven't. Can I actually go to trajectories for this? I haven't decided the materials.
Because there's trade-off within materials, so we want to look into what is best for the current criteria that we have. But of course, the main concern is we might want to look into biodegradable to actually solve the littering issue.
So what are the criteria?
Because initially, the two main points of our entire system is to actually initiate the rainmaking and to initiate the aerosol dispersion. But now we have cut down the rainmaking. So the main concern is we are not going to look into the balloon at the stratosphere, it will be at the bottom, which is that troposphere. So the idea is that as long as our system can maintain within the troposphere, we don't have to actually look further into that. So our boundary is within the troposphere. And if we actually maintain to solve the rainmaking criteria, then we will actually pick on that material. If it, at the same time, it actually holds the payload amount, so that will actually sums up the material that will identify here.
Did that answer the question you were asking?
Not really. So what are the criteria you're assessing to choose your
The main
material?
priority is biodegradable properties.
Why?
Because to solve the littering issue. Yeah.
As well as these other 5 would probably be the criteria that we're designing to as well.
I'll just make some comments, I think, and perhaps ask a few questions. Firstly, I think that what I would have liked to have seen you lead into in response to Matt's questioning was what kind of trade-off analysis you used or are you using, whether you used a QFD type analysis or whatever you may have done. I would have liked to have seen that highlighted throughout the talk, in fact, because that's the technique that you are using, I believe, to do the trade-offs and to actually decide what the criterion are based on wants and needs and all of those kind of things. The second thing is I would have liked to have seen you give a clearer indication of what the alternatives in each case in each of the 4 areas were and why you had chosen, or if you had in fact chosen one over the others, and why you had chosen that. And at the very start, I would have preferred to see a clearer description of what the problem was that you were trying to solve and what your proposed solution was, perhaps. I mean, you did that in the end, and that's good. Otherwise, I think the talk was good. Obviously, you've put a lot of work into it. But I guess just remember that you're presenting to an audience, you should be presenting or planning to present to an audience while having some expertise in the area, don't know what you've been up to and don't know what you've been doing, and are interested in finding out how you've come to that final kind of solution or to the solution in the end.
Can I also ask another question following on from that? So I saw you break down into your different systems, and you talked, there was a diagram that had arrows pointing between, which was sort of suggesting some interaction between the different groups. Can you elaborate on what those arrows actually represent?
The
So
arrows
what
are
information
Sorry,
flows through those
they
arrows?
represent the influence the different systems in part over the others. So like the rainmaking is the main, like where we start, so we have to make rain. So that influences the size and weight of the payload, which influences the size of like the trajectories and all that. It's and then the chemicals, the transportation, so everything has to be transported and launched. So yeah, it's just the influence of one system imparts on the other.
You should clearly articulate what those things are. So you should say that like goes that way, you should say what travels in the other direction, because they're your interfaces between the different systems. There are a lot more than that as well, in terms of how you connect, how you hold, what data transfers between different systems. There's a whole range of different things, and I think that is very simplistic. And even when you talked about later on data flowing from different systems, that's not represented in that diagram because you don't have an arrow pointing in the right direction.
Yeah, I would have liked to have seen your full influence diagram somewhere, just even if it was for as an example of what you're considering. And again, with those the influences actually what's passing between and what's going through that highlighted. Otherwise, I'm happy. Thank you very much for the talk.
Thank you.
Matt and I will decide whether you actually get any marks at all for it or not. Sorry, I shouldn't joke on these occasions, should I, perhaps? Thank you. We'll let you know soon, and I'll report to Liam, and perhaps you'd like to also write up something for Liam.
We have the video to show.
Okay. You can take videos with things like that. I wondered what this guy was doing. Okay, thank you.